Hey, welcome everyone. Welcome back to this live stream that we're doing, that I'm doing. And what I'm building is a Docker CLI. And the main reason is just to understand what containers are, how they work. So that way, just I have a better understanding. And the best way for me to understand is to kind of share what I'm learning. And so today's going to be a little bit different. Last time I had a lot of code kind of pre-written and I walked through it. And this time there's going to see, what you'll see is a little bit of a research spike and kind of how I go about gathering information and taking notes. I've done a lot of different note taking systems. And to be honest, kind of the best way is to just pick whatever tool works for you and to ask questions and then to answer them and capture those answers in the form of notes. So to kind of recap, let me go ahead and pick out the correct layout here and share my screen. And then we'll kind of recap what I was able to accomplish in the last session, and then we'll pick it back up. So this should be the screen. So TechDoofus, if you are watching live or if if you watch the recording, you can shame me a little bit. I had to go back to VS Code. I was in the middle of trying to apply all the cool things that you shared with me around the config, and I completely destroyed my configuration. And so that's host. My NeoVim configuration is host. So I am back in my home, my home turf of VS Code right now. And if we want to take a look at this, what I was able to kind of accomplish in the last session, make the font a little bit bigger here, is I was able to create two subcommands. I was able to create this run command. And so that is kind of mimicking the Docker run command right now. And what it's been able to do, what I've been able to do with that is to isolate the host name. So using Linux namespaces, I was able to isolate the host name and then domain names, but also the processes. And then we use another namespace called mount to mount in the process directory. So that way it's processing information. And if we want to see that run, we can go in here from the live stream, and let me just show that URL that I'm using right now. So it's on my GitHub. Containers from scratch CLI is where all this code is. I forgot to push these changes up, so after the stream I will definitely do that so you can see exactly what I've written. There's versions of it in the root of the repository that do the same thing, but it's kind of nice to see kind of apples to apples versus apples to oranges. But anyway, if we get back to this, right now what I have is 3 files. I've got my Go mod, which is of course just my module file, and then I have the main. And in the main, I have those subcommands, but I'm also using a Ubuntu file system to be able to mount in the processes because I needed to use the chroot command, our system call, to be able to create a new file system for the container, and that way it has a process file that I can pull from the host process file, and that way I can mount it and get that process isolation kind of wrapped up, so to speak. But if we want to see this run, instead of building the binary, I'll just do the go run, and I'll call all the files in this. I guess I could do main in this instance because I'm not separating out my files yet. And then the subcommand is run, and then I want to do bin bash. So that's the path where bash is located in my new Ubuntu file system. If I was doing Alpine, I'd have to use point to the shell because I don't think bash is on the Alpine distro. But if I do this, I need a, and all these need to be run as sudo. So let's do that, sudo. So I'm now passing that argument in. And if you recall from the last stream, you have to create the process with the namespace. And then inside of that now namespace process, you can create additional processes. And so that's the child that's being run here inside of the proc inside the namespace. But now I'm in a container, and this container has a new host name, which is container. And you can see that now listed in my prompt here. And I also get an isolated view of processes. So that's what I was able to accomplish last time. And just to prove that out, if I exit that and do host name, it's going to be different. So now I was able to isolate that host name. So what I want to do now is I'm kind of okay with the concept of namespaces and how it's doing isolation. There's different namespaces that we can use for additional isolation, one of them being the network that I'm not going to worry about quite yet. Now I want to know how I can constrain these resources. How do I prevent this container that's now sharing the kernel with my host operating system? How do I constrain the number of like maybe maximum memory or what have you. And that's probably somewhat familiar if we look at some of the Docker commands. So if we come like kind of full circle back here, the memory limitations, essentially what I'm trying to do is look at what Docker's doing and then write my own version of that and go. That's the whole kind of point of this project here. And if we look at this, when we use the Docker run command, we can set some memory limits. And so I want to kind of figure out like what's the backend mechanism for doing that. And if you dive a little bit deeper, you'll find out that the C group is that. And one of my very first things that I do when I go and try to research a particular area is I just Google it. And so the first thing is usually Wikipedia in some sense. So if we look at the Wikipedia here and just define what C group is. So C group is an abbreviation of control groups, which is a Linux kernel feature that allows you to limit and isolate the resource usage. So CPU, memory, disk, IO, etc. For a collection of processes. So if you kind of go back, what is a container? What's a process that's been isolated with namespaces? And so this is a way that we can attach C groups to them to limit the resources. So what I've done a little bit ahead of time is I've kind of posed some questions to myself. These are the questions that I want to answer in the stream. So the main thing we kind of already answered here is, what are C groups used for and how are they related to Docker? Well, Docker uses C groups to constrain resource usage. And this is really all the fancier my notes get these days is I just post questions. I kind of create a new note. This is called C group. And then I just start to answer questions. Let's make this a little, if I can make it bigger, I will. It doesn't let me. And now I want to know, like, how does Docker use C groups? So from that first blog post that I pulled up, it looks like we can, at runtime, with the Docker run command, we can set these limitations. And so that tells me that I should include this inside the run command that I have. And now if we go back, what is a C group? Well, typically what I do here is I'm lazy and I just copy from different things. So I'll just copy this and I'll throw it in my note. And these are good just to review every now and again. And there's a site that I don't really care to include in here. Oh. So if you're curious, the application that I'm using right here to take all these notes is called Logseq. And we'll just leave that for now. I can clean them up later. So now I want to know how do C groups work and where are they located? So how do they work? Go down here. Let's add another one. Like how do C groups work? And this would be, let's see here. Let me find a link for everybody. There's a great chapter on C groups in a book called Container Security by Liz Rice. Let me get a link for that. Here's a Goodreads link, and then you can kind of find it in the various publishers. So we'll do a banner for this. Show it. I'll put that in the comments. Container security. That would be it. And in there, I found out, if we go back to the Wikipedia page, I think it'll tell me. Maybe it won't tell me where they're found. No. So let's go to my other notes, which I took on the book. So if we pull over Obsidian, I kind of switch back and forth. I want to know, how they're related to containers, but also like where they're found. So here they are. They're in this sysfs group. So if we just go back over to VS Code, let's browse around in the terminal. So if we change to, I think it was sysfs C group, and we clear the screen and take a look at this. Here are all the different C groups, and you'll notice that they're in they mention, the documentation will mention that they're in a hierarchy. And this hierarchy is separated out by the different resources. So if we were to go look at, say, memory, for example, and I've got a custom one in there. So if we do memory, you can see all the different C groups that are in here. And not too surprisingly, because I've got Docker Desktop installed, there is a folder in here called Docker. And if we look inside Docker, you can see that it is defining a bunch of different things. So Docker Desktop has constraints like how much CPU that you want to use, how much memory do you want Docker Desktop to use, or the containers that are being run inside Docker Desktop. And this is most likely where all of that is actually happening on the host. But if we look at this, there's other ones. There's memory, there's CPU, and net. And then I remember the other ones. So we can also constrain PIDs or the processes, which is kind of what I want to do in the code. So if we go back to my notes, let's just copy this here. Let's include this. We'll make some fancy syntax for it. Now, how do we create one by hand, right? So before I try to do any kind of coding, I kind of try to figure out, is there any way to do this from the terminal or manually? And the answer is yes. So if we go back to VS Code, we can create new C groups by just creating a folder in here. And it's pretty interesting because it'll populate this folder. So if we go, let's do the memory. I have one in here called Josh, it looks like, maybe. Oh, I cleaned it up. Cool. So look at in here, we've got all these different ones, and the ones that are folders. So there's the hierarchy, which is here's the top level of the hierarchy, the very top. These are all the things that we're limiting here. And so these would apply at the most level. But if you create folders inside of here, then you have more fine-grained control. So Docker is setting things more specific than what these are. So if I were to create a new directory, we'll just call it container. We got to do root because we're messing with some serious files. If I create, we'll just do Josh again. We'll do container, most likely when we write the Go code. And then if we change into that, notice that it creates a bunch more files. And if we look at these files, the main one that I want to be so these are like all the different things. I don't even know if Docker has the ability to manipulate all these different C groups. But one of them, if we looked at the website, is this memory limit. And I'm just going to assume, just have a slightly bit of experience using it, that the memory max limit in bytes is what that would be. So if we cat that memory limit in bytes, it'll be all the available memory on my system. So I don't know, I think that would probably transfer to, what do I have on my system? 64 gigs or something like that. That's how much memory I have. And so it's letting it use all of that. And if I were to even just echo into that file and change that, it would reduce the number of memory that any process assigned to the C group would have. So that's kind of the next C group, or the next question. So the answer to this one, just to recap, how do you create it, is you create a new directory inside C group that limits the resources you want to constrain. So I wanted to limit memory, so I created a new folder inside memory. And now I can manipulate the values that are inside of this to change whatever process is assigned to that C group, what they'll be able to do, what they'll be able to consume. Now that naturally leads to the next question that I had, which is, how do you assign a process to a C group? And to be honest, a lot of my first stabs at these, what I'll do is I'll take my question, and because AI, I mean, not to mention AI all the time, but honestly, I think it's reduced my Google search stuff by at least 40-50%. And a lot of times I'll just come in here and say, like, how do you assign? I'll just ask these more specific questions because they're more fine-tuned, right? And I start to have a dialogue, and we'll see what it comes up with. Okay, so there's a set of tools that you can do. How maybe I need to be more specific on Ubuntu. Oh, there we have it. Actually did give me the right answer eventually. So, oh, that's interesting. Looks like there's some tools that are available. That doesn't make the font bigger on there. To create the C group. So instead of creating the folder manually, there's some tools, which isn't too surprising. But here's the main thing. What you want to do is you want to assign it to the group tasks. I don't think that's quite it, because what I was reading in container security, if I pull that up, it needs to go inside. I think it's the processes. So each thing in here, I need to just close that. So I stop going to it. Yeah, we'll close that. There we go. There's a proc file in here. Yes. Okay. This was what I was reading in container security. There is this C group proc. And if we look inside that, if we just cat C group proc, I'm not going to see anything. So inside my new C group, there isn't anything here, but this is how you assign it. So you can create the C group and create all the limitations you want, but until you assign processes into it, there's not going to be any constraints applied. And that's how you do it. You would append them, you could echo them into this file or add them into it. So now I kind of know what I want to do. I want to limit the memory bytes, but I also want to limit PIDs. So I'll probably create another file inside PIDs. And that's what we'll dive into here to get it kind of wired up. Let's see here. So inside, what I want to do is I want to call a function inside of run that calls this C group before the command is run. And this will assign, so inside my C group function, I want to do all that stuff. I want to create the directory. I want to modify a file in that directory to create the constraint. And then I want to add the process into it. And so I'll just type C group as a function here. And we won't need to pass anything into it, I don't think. But I also want to return an error. Okay. And so instead of kind of repeating this all out, what I'm going to do is I'm going to create two types. Well, one's a type and then one's an embedded type. So if we go up to the top, there we go. Now my keys are working. Doing the reverse of what I want. All my Vim mappings. I miss NeoVim already. Okay, here we go. First, I want to create a limit. The limits. Well, let's create the bottom struct first. So type limit struct. And in here, if we were to create the file, I need to know the name, I need to know the path, and I need to know like the parameter or the value that I'm passing in. Yeah, so name can be string. All these are going to be strings. Path will be a string. And then we want the param. Oh, yes, yes. So I want the path to the C group itself, and then the parameter is going to be what am I going to manipulate inside that. So if it's in the PIDs one, if we take a look at that just real quick, back to directories and change into is it just PIDs, there should be a max PIDs. If I create, let's just create a new one in here. what are my options? PID.max. So if I create a new C group, one of my options is to constrain the maximum number of processes inside a process. So I guess the number of processes it can spin up inside of itself would be one. So if we were to look at that, the C group path is going to be this sysfs group PIDs Josh, or whatever the name is that I'm going to give it the C group. And then the parameter is going to be this, like PIDs.max. Like, what is it that I want to manipulate? So the param will also be a string, and then all of the values are a slice of wheat. And to loop through it, what I will do is I'll create an embedded struct. So if I do type limits struct, it's going to be, it'll just say limits and then a slice of limit. So that's called an embedded struct. Those with more Go knowledge, please feel free to correct if I misspeak. So now that I have that type, go down. Call, well, I'm trying to find, silly. That's what I need to do there. And then I need another function underneath child. And these would all be good things to kind of extract out or decouple later. But now we're just going to do it all in the main because it's fun. So inside the C group, what do I need to do here? I need to define all the options for the limits. So if I do C group limits and equal limits, literal limit be these in here, and we'll do PIDs will be the name. Although the complete accurate, and we'll say 20. So that byte will convert to 20 processes inside that file. And now memory. Nice. Won't lie. I think that's all coming from Copilot because it's reading my other code examples. Memory and bytes. And again, if we looked over, change back into memory. Memory Josh. One of the files in here, what we can limit is this memory and bytes. Limit in bytes. So that's what I'm passing in there. So name is memory. Path is this. So that I believe what's going to happen is it'll combine these two. Not sure what I'm using name for. We'll get to it. And then we want to do the value. And what did I want? I think I wanted like 1 megabyte, which was a byte. What is it? 6 zeros. Put it over here. Copy and paste so I don't mess it up. If you do too low, the bad thing that'll happen is it just won't start. It starts with too low of memory. And then I also wanted to limit the CPU cycles. So this was one that we didn't look at yet. But if we CPU, C group for CPU is that path, and then I want to do the number of shares, and I think I said like the number of cycles. I was able to constrain it if I were to do 512, because I think the most, you double this number, that's the typical upper bound of shares on a CPU. At least I think the AMD 64 architecture. And so essentially what I'm saying here is I want to limit it to kind of like the halfway mark. So now essentially instead of like having to repeat create file, modify file, and then add the file to the process, I'm going to do a for loop for all this stuff, or yeah, for range loop. So for, and I'm going to throw away the error because I don't care. We'll do range C group limits. And then here, yeah, let's put out an error message. So setting S to S, so the path and then the value. So every time this goes through the loop, I'm going to print out what it's doing. And then I want to make the directory. And we don't need to do the make R or L, because if we're inside the C groups, the C group should exist if you're on the right system. Now this gets tricky, and this is where kind of the value of the Docker command line is. They've already thought of all this stuff. So this is going to be kind of really hard coded to Ubuntu, because the C group location is different on different distributions. It just so happens to be the one above in Ubuntu. So if I do path, then I want to, I need to join. Yeah, so make directory, and then I want to do file path join, and it should be l.path and then the parameter. I don't think I need anything else. No, I do. Oh, I'm getting confused. I just need to create the path directory, because that path will include the name. Oh, okay. I need to update this to have the name of the C group. So right now I'm just giving it the path, but I also need this to include the new name. So I want container. Instead of Josh, the C group that's going to be created is just going to be container. That way I don't need to do any joins. This is going to create that new C group underneath all of this. If I just left it with that, it wouldn't, yeah, it would already exist, and it wouldn't create any additional C groups. So now when I do the make directory, I just need to do the path. So mkdir, and then I need to do l.path, and then we'll give it permissions. And I can't remember off the top of my head what that means. All permissions. You do? Drop it in the chat. All right, so error. Now what I want to do is to write to the file. I want to write the value to the file. File path, and I need to join this time. Path and the parameter. So l.path, l.parameter. Then what value do I want inside of the file? And I want the value from the limit. So L is just the shorthand for the limit. It's going through each limit inside of this list, or custom type, really, the slice of limit. And it's going to set the value. And then the permissions on that file are going to be 0700. We'll handle any errors. Return the error though. On the top. Didn't, but we want to. So we got the first and second step done. We've created the directory for the namespace, and that was what I was doing when I was creating the make directory. And then I also have set the value in there. So that's going to go through all three. It's going to set a CPU C group. It's going to set a PID C group and a memory. Am I saying that right? Yeah, CPU, memory, and PIDs. I'm gonna do 3. Now what I want to do is write the process ID of the current process. So this will be the bin bash into the C group, so it's constrained. So the new session, the new process that I'm calling inside the container that's running inside the container, it's going to be added to the C group, so it's constrained. And that'll be air util file file path join. And again, it's at C group proc. So inside each of those new C groups, there is a file called C group proc, and that's all the processes assigned to that C group. And to get the byte, oh, there it gave it to me. What I need to do here is get the current process ID and convert it to a byte. So I'm using the string convert. And then I'm passing it into the bytes. Passing it as a byte. There we go. So if error not equal nil, we'll do an error and return the error. And then if all that's fine and dandy, since I'm handling an error up top, I still need an empty return down here. So return nil. There we have it. Okay. What are we missing here? Missing curly brace somewhere. Right there. Maybe I've got too many. No. Let's zoom out just a little bit. Where's limits end? Limits ends there. That's right. Oh, I don't think I ended my 4. And added my imports. Should work. Should work. Let's create a new terminal. There we go. We're in the right directory. We'll change into live stream. Just did here. Okay. So now the code that I've got, make sure I'm calling it. I think it's because it returns an error. That's going to be C group. Remove that blank identifier. Returning an error. It should return an error. Oh. No? Weird. See what I'm missing? Cleared wrong. It needs to be in brackets. Now it should yell at me. Handling the error? It's funny how your brain turns off when you know someone's watching. Let's see here. C group. Yeah, it should yell at me. Handling this error. It should be error. Oh, I need to replace this. That's what I was doing wrong. Take that out. Now, if error equal nil, panic. There we go. I was doing that wrong. Okay. Now let's give it a try. So go run. Well, we didn't really change how the command is working. Go run main.go run bin bash. I love that that meme. I don't know if anybody's seen it. That meme it says "Make me a sandwich," and it's like, "What do you say?" And then you say "sudo make me a sandwich," and then makes a sandwich. Signal killed. So we set it to 20. Set this to 1,000. I wonder why it killed it. Killed from proc name. So from inside the proc and then signal killed. I wonder what one it doesn't like. So that typically, when I've run into this before, this typically means that I didn't give it enough resources or something and it's killing it. So I wonder if I need to add some more memory to it. There we go. I had too low a memory for the container to start. So I was probably missing a 0. But now if we look at, we're in the root directory. Yeah, so if we look at the sys fs, oops. Oh, I know why. So this is going to create the C groups on the host. So if we just split this terminal, it might be easier if I just create a new terminal. I've got the container up and running. It wouldn't do any good to modify the C groups that are inside the container, which would be in here. lssys, because that would make it the host. These C groups need to be on the host itself. So if we create a new shell, memory serves, if we do, let's just change into it, C groups. There should be something in process. So if we go into PID now, should be one called container. And in here, the max PIDs. So if we look at this max PIDs here, this should be 20. So let's cat that PID max. And did I have that command? I wonder if I have that command. So in her talk, Liz Rice, she did a fork bomb to prove out the processes and show that it would never run above 1, but I don't know if I remember if I put that in here or not. I did stress to stress memory, but I didn't do the PID or the fork bomb, which is fine. But we can see that it's set there. Move that up all the way. So I'm inside the container, got a limit of 20 processes. I wonder if I have the stress tool loaded anywhere. No, it must be on my other system. That's fine. We'll just have to go by its word for now. Maybe that would be in the next stream, is to test it. All right, what else do we need to do here? Let's look back at it. That took less time than I thought. I think that's good for the run. The run command. Yeah, so if we recap, what the run command now does is it creates namespace for process, namespace for the host name, constrains a couple things, and those are all handled by the Docker run command. Now it might be time to move on to the build command. Let's see. And then we're kind of caught up. I can switch over the code base. Maybe I should recap these. Yeah. I was just trying to think if there's anything more I want to cover with the C groups. It's like I've got a lot better understanding of what they are. I do wonder what are allowed, like how you is all that you can do with Docker is just the runtime. I wonder if you can't limit that. Like in Kubernetes, you can limit it in the manifest. This constraint's there, and that's being translated into the runtime. Look it up. See if you can find anything. Runtime options. It looks like it's only runtime. It's not an instruction that you can put. Instruction. No, it's all with the run. Does anybody know? Is there any other way than the Docker run command to limit it? I don't think so. Must be all with the runtime. Let's take a look. We got from label, working directory, expose. Yeah, it's all got to be a runtime, which I guess makes sense because the C group won't have any value. You have to have the process ID to be able to do that. So that makes sense that it would only be a runtime option. Because if it's not running, if it's not started, you won't have a process ID to put into the C group to do that. Okay. So this was the point that I got last time where I started to refactor some of it because it's getting a little bit long. And so I think I mentioned this in the first stream, but the building modern CLIs in Go, and then also the I think Go, they just released Go organize. Oops, nope. Golang project structure, I think is what I Googled. They just released some guidance on project structure. How to write Go code, organize module. Let me throw this in the chat. This is pretty helpful. A lot of people have been waiting a lot of time for this. Let's put it as a banner. Oh, there we go. Yeah, so Go Dev, docs, module, layout. And this is just some like general guidance for how to lay out your Go project. This is, I think, the Building Modern CLIs in Go by Marian. Let me get a link to that too. She goes in a lot more depth because her whole book is focused on CLIs, but they do have the same recommendations for a very basic app, which is what I'm working on, which is the flat structure. Let me just make sure I Building Modern CLIs and Go. Got to promote the book because it's super good, and I'll put a link in the chat for that. But the basic guidance, I think it's what am I following? Basic command. So if it's an executable, which is what I'm working on here, I haven't turned it into one. I've just been using Go run, is to do this. So you just have it's called a flat structure. You just separate the different files. And how I can do that, I'll just do it in the live stream folder, and then I can actually just switch back in the next stream to the root directory, and that's a good transition. That way I don't have two code bases to go off of. And then we're all caught up, and things will probably move a little bit more slower as I fumble through trying to figure it out. But anyway, what it says is in the documentation is you should just create your project root directory, which for me, in this case, would do that live stream subfolder. And you have your go mod, your main, and then you can have these different separations. And so for me, I probably want to separate it by command. And if I do that, I would want to create a new file in here called run, not fun, run.go. And they're all going to be part of the main. So I believe you still say package main, live stream main. And then here I do my import. So let's just grab all the run stuff. The function. I'll leave the commandlet, the new flag, I'll leave that subcommand set here. I can move it later if I wanted to, but I'm just going to grab the run, the child, and the C group, because that all relates to the run command. I'm going to move that in here, and then I think my awesome VS Code plugins are just going to fill in all the imports I need. Oh, and I need to bring over the types. Let's bring the types over after import. It took me a minute to figure out because it's very interesting, like the package name. So if I were to create a CMD and then have some sub packages, I'd have to do a little bit more. I'd have to actually import that over here, and the imports from main and so forth. That's kind of been, I don't know, a sticky point for me because I don't do it a lot. I usually just work in main. I'm working on smaller stuff. Away. Let's make sure that matches what I've got. Yep. Should be able to find it just fine. As long as I'm importing main on both. What is it yelling at? The file within the module live stream, which is not in your workspace. Fix the problem. Go work. Okay, the workspace. Care about workspace. It should work. Let's give it a try. But instead of doing main, I have to just call all the files in here. Sudo, of course. Okay, so that works, even though it's yelling at me because I'm not creating a workspace and all that good stuff. It's working. Oh, yeah, just to recap, essentially all I did there was move out all the functions related to run and put them in a run.go and still declare the main package. I could also output, I could do a go build and get a binary from it. But a lot of times when I'm developing, I just do go run. But you do need to make sure that you're calling all the files, because if I did main.go, main isn't going to have everything in it, and it's not going to load that in there, and it's going to say that run and child are undefined. I'm just going to say run all the go files that are in this directory. Crashes because I'm not doing sudo, but that's how you do that. So next time, we're almost at time, close to 10 minutes. My goal was an hour. We got pretty close. Next time, what we'll do is we create a new file called build. We'll start working on the build function. Right now, we just have this stubbed out where it's printing out the arguments that are being passed in. And so my main goal is here, we'll probably do a little bit of a research in the beginning because I want to figure out what exactly the Go file is. And I actually found this is pretty hysterical. There's a lot of truth to it. Let me find the bookmark for Twitter. Someone, Aaron Prindle, works on the Google Cloud, I believe. He has a pinned tweet, which is fantastic. Let's pull that over here. And we'll see that there's a lot of truth. Oh, get back here to his pinned tweet, which is container image. What? It's all a tar balls? It always has been. So those are all the layers. But what I want to do is I want to create a build command that essentially can remove my need for having this Ubuntu FS right here, root FS. I want it to be able to pull it down, like download it, and then create, like mimic the layers that are being created and all that good stuff. But I also want to create it to the OCI spec. And then we'll find out kind of like what's underneath that. So that's kind of my new frontier for the build command. But we'll wrap up this stream. We were able to do the C groups in this amount of time, which is cool. That's your ability to constrain resources. That's how Docker is constraining the resources. And you do that by just creating a file underneath the C group directory. There's some tools that you can use for that too, CLI tools, but we're just doing it by hand. And then you have to add the process in there. Otherwise, it's not going to constrain it. But that's it. Next time, we're going to talk about container images, what they are. We'll probably spend some time tinkering around, tearing apart, and trying to mimic that with the build function. So with that, yeah, follow me if you want to keep up to date with this. I can't schedule these on Twitter yet or X. So the best way to get notified there is just to follow me on Twitter and you can hit the notification. These are currently being put on YouTube and LinkedIn. So those actually have pages that you can follow, subscribe to get notifications. And then let me know if there's anything that you want me to go deeper into or revisit in this, because this has been super helpful for me just to solidify my understanding of when I run Docker commands and when I deploy these containers to Kubernetes clusters, what's happening? And that's giving me a better understanding so I can write some more tooling around it and filling in some gaps for me in the open source projects that I've been working on. And I hope that it's doing the same for you. So thanks for watching. I'll hopefully catch you on the next stream.